Hello and welcome to our new section, Understanding Numerical Operations with NumPy. In this section, we are going to look at creating, indexing, and manipulating 1D and 2D arrays. We'll see some widely used functions, methods, and attributes in NumPy, probability and statistics with NumPy. What's the NumPy package? NumPy is the fundamental package for scientific computing with Python. NumPy arrays are, unlike lists, allow for mathematical operations over an entire array, allow for vectorization. They are based on C, thus faster than Python lists. Arrays are of single type, numeric, string, or Boolean, unlike lists. So first, we'll start with 1D arrays with NumPy. In this video, we are going to look at how to create 1D arrays, how to index or subset an array, slicing an array, perform logical indexing on arrays. So let's start. First, we'll import NumPy as NP. So NP is the alias that we'll be using instead of writing the whole name, which is NumPy. So we'll make a shortcut and just write NP when we import a library in this format. And this is common in Python. So later on you will see like pandas, for example, which is imported generally as import pandas as PD and etc. So let's create a list. X is equal to 150, 200, 300, 450. Okay, now this is a list, as you can see. In order to convert this to a NumPy array, we'll be using np.array. And if you pass in the list, and we get a NumPy array. Okay, so np.array, that function that converts a normal Python list to a NumPy array. And we can, let's save this into a variable called y. And let's see y again. So if you say type x is a list, and if you say type y is a NumPy array, as you can see. So in lists, Python lists, numerical operations were like, plus, for example, was not adding up the values, but it was just concatenating the lists. And x times 2, or let's use x times 3, make it more, or x times 4, would just multiply the list 4 times and then concatenate them. So would create basically 4 of these lists and then concatenate them. So, but the main difference between the Python lists and a NumPy array is that in NumPy arrays, we can do mathematical operations. So when you say y plus y, it will add up the values of y and you will get the result like this. So if you say y times 3, it will multiply each value of y by 3. It's not concatenation anymore, it's a numerical operation. So that's one of the main differences. And as you can see, we are operating on the whole array at one go. In order to achieve this in Python list, you had to write a for loop and then go over each of the element and then go from there. But here you can just do it in just like this, very easy. So let's now see how to do subsetting and slicing and indexing in NumPy. Let's add a few lines. So we have our NumPy array, which was y. If you want to reach the first element, again, you can just use y0, for example. Or if you want to reach the second element, change this. Or let me say, it gets confusing because it starts with 0. Okay, the first index is 0. If you say first, second, it really gets confusing. So let me use the word index. So if you want to reach the element at index 3, you can write y3, which is the last element. Okay, so because it's 0, 1, 2, 3. If you want to do slicing, so let's say 0, 2, 3, then you will get back 0, 1, and 2 elements at index 0, 1, and 2, which is these 3 elements you get it back. You don't need to write that 0 if you start from 0 like that. So you can just write this. That's also fine because the first element is automatically included. If you want to go to the last element, let's say from 2 to the last, you don't need to put anything here. You can just leave it empty and it will include 2, 0, 1, 2, which is this one, and then 3, the last one. Okay, you get it back. If you want to reach the last element, or let's say fetch the last element, you will write y minus 1. Again, everything is the same with this, like in the Python lists. Okay, so you got back the last one. And finally, you can say minus 3 to minus 1. You will get, so this is minus 1, okay, 450. This is index minus 2, and this is index minus 3. When you say minus 3 to minus 1, remember last index is not included. And when you do slicing like this, last index is not included in Python, so you get 200 and 300 back. Okay, that's it for subsetting and slicing and indexing. Now let's do some logical indexing. or you can call this Boolean indexing as well. Now, as I showed you before, we can do operations in one go in NumPy arrays. So what I'll do here is this. So we have our Python NumPy list, NumPy array here. If you say y, let's say greater than 200, you get false, false, true, true back. Let me keep that y here. So if I say y greater than 200, you get a NumPy array. This is also a NumPy array, a Boolean NumPy array. You get false, false, because these two are not greater than 200, and then true, true. Now, let's show some comparisons. If you want to compare whether something is equal, you say 300, for example. Y is equal to 300. It will compare these values, and you get false, false, true, false back. If you want to compare not equal to 200, so you get, this is true, right? This is not 200, so that's true. This is false because this is 200, and true, true. Okay, so that's how it works, and you can get, greater than or equal to, or you can get less than or equal to, etc. So this information can be used to do subsetting as well. For example, if we want the values greater than 200 out of this NumPy array, we say y greater than 200. And then if we put this back into y array, so we are saying y greater than 200, and then we put this back into the y array. We run this, we'll get 300 and 450. So what we are saying is, give me back those values in y which are greater than 200. And it will only return those true positions. So this was giving false, false, true, true. And it will give you back those values at the indices where it corresponds to true and true. So these last two will be returned to you. And you can apply this to any of these as well. So for example, we want those values which are not equal to 200. Y is not equal to 200. We are saying, give me those values in y which correspond to the indices at which the value is not equal to 200. So when you look at this one, so we get true, false, true, true. So only those values at the indices that are true, true are returned. So it's 150, 300, and 450. All right, and that's all. So we have learned in this lecture how to create NumPy arrays, 1D NumPy arrays. We have made a comparison with the NumPy lists and how it differs. We have learned about indexing and subsetting using index values. And then we have finally learned about logical indexing using comparison operators.